Hi all, welcome back to Tech Time with PK. Today we are going to discuss about how to integrate SSL certificate with OVH Cloud LoadBalancer. I will be using Let's Encrypt and Certbot to obtain the certificates. Let's Encrypt is a open certificate authority which provides SSL certificates to websites and applications, and it's supported by all major browsers. Certbot is a tool which helps us to obtain the certificates from Let's Encrypt. I will show a quick presentation about our setup. We have internet here. First of all, we will create a private network with a gateway attached to it. This allows internet access for the resources created inside the private network. After that, we will create 3 private instances on this network. We will install Nginx web servers on these instances. These instances will be connected to the load balancer later. Next, we will create another private instance called Cert Manager. We will connect a floating IP to this instance. This allows us to access the instance using SSH from the internet. Then we will install Certbot and OpenStack client on this instance. These tools helps us to obtain and install the certificates onto the load balancer. After that, we will create a load balancer with a floating IP attachment. Then we will map a domain record for this floating IP. After that, we will create SSL certificates for this domain using Certbot. Then we will upload these certificates to OpenStack Secret Store provided by OVH Cloud using the OpenStack client installed on the Cert Manager instance. Next, we will configure the load balancer to collect the certificates from the OpenStack Secret Store. After that, we will connect the Nginx web servers to the load balancer. That's it. Our load balancer is configured with SSL certificates and it's ready to accept HTTPS traffic from the internet. We have done the theory part. Now let's move on to the practicals. I'm on OVH Public Cloud dashboard right now. From the left side panel, click on Private Network. As of now, we don't have any private networks. Let's create one by clicking Add a Private Network. I will choose one AC region as my deployment mode and London as my location. For the private network name, I will enter my private network. And for the VLAN ID, I will set it as 1. I'm not changing the subnet configurations. Check this option to connect a gateway to this private network. OVH has assigned a small size gateway for my network. You can see the cost here. Click on Configure Your Private Network button. This will start creating our private network. I have done a detailed video on OVH Cloud private networks and gateways. You can find it on my YouTube channel. See, our private network has been created. You can see a gateway connected to this network. We have successfully created private network. Now we need to create 3 private instances and install Nginx web server on it. Let's click on Instances. Click on the Create an Instance button. We need to select the model of our instance. I am choosing D22 from the Discovery series. For the deployment mode, I will choose one AC region. For the region, I will choose London. For the image, I am selecting Ubuntu 24.04. I will select my SSH public key here. Next, I need to configure the instances. I will increase the instance count to 3. For the instance name, I will enter Nginx. We have to add the post installation script here. I have already prepared a script to install and configure Nginx web server. This script will update the package repository, then install Nginx web server. After that, it will replace the default welcome page of Nginx web server with the hostname of private instance. Let's copy the script and add it on instance configuration. I have to configure the network next. I am selecting private mode and I will select my private network. Next, I have to choose the billing. Since this is a test setup, I am selecting hourly billing. Click on Create an Instance button to start the creation process. This will take a moment to complete. Let's wait until it's finished. Do not refresh the page until it's finished. OVH will direct us to the instance listing page once the instances are ready. See, our Nginx web servers are ready. Now let's create the Certbot instance. Instance configurations will be same as of Nginx web server. D22 model, London region, Ubuntu 24.04 as image, same SSH key. And for the instance name, I will enter Cert Manager. We have to add the post installation script here. I have already prepared a script for installing Certbot and OpenStack client. I will explain the script. First, it will update the repository. Then, it will install Python pip package manager and virtual environment. Then, it will create a virtual environment. We will update the Python pip package manager on that virtual environment. After that, we will install necessary packages required for OpenStack client to work. That is Python OpenStack client, Octavia client, and Barbican client. Next, we need to install Certbot to obtain the certificates from the Let's Encrypt. I'm using Snap Package Manager to install Certbot. Then, I will install Certbot DNS plugin for OVH. I'm using OVH for managing my DNS records. That's why I have installed Certbot DNS plugin for OVH Cloud. If you are managing your DNS with other providers like Cloudflare or DigitalOcean, you have to install the Certbot plugin for that. Just go to Certbot official documentation. Here, just select my website is running other on Linux NAP. Then you have to select wildcard here. Then you can see all the commands and instructions for installing Certbot using the snap. You can see these commands on my script. Now here we can see the documentations for DNS plugins supported by Certbot. Click on that. These are the DNS plugins supported by Certbot. Let's check Certbot DNS plugin for Cloudflare. If you are managing your DNS records with Cloudflare, you have to follow these documentation. You have to get the Cloudflare API token and add it here in the configuration. Then you have to run these commands to obtain the certificates. I will be using the Certbot DNS plugin for OVH Cloud. You can find the plugin documentation here. Let's use this documentation to configure the Certbot later. Now let's use this post installation script to complete the instance setup. Configure the network with private mode and select the private network. Check attach a floating IP to this instance. Then select create a new floating IP. For the billing part, select hourly billing. After that, click on create an instance. Click OK to continue. Our instance is now being created. Let's wait for a moment. I will be back once the instance is ready. As you can see, all our instances are ready now. Our Cert Manager instance has been assigned with a floating IP. We need to create the load balancer next. From the left side panel, click on Load Balancer. We don't have any load balancer created right now. Click on the Create button to create one. I am selecting the same deployment mode and location as our private network has been set up. I will choose small size for this load balancer. Next, we need to attach a floating IP for this load balancer. Then we have to select the private network. I won't be adding any instances to the load balancer right now. We will do it later. Click on skip this step. Then we need to enter a name for the load balancer. I am entering my LB as my load balancer name. Click on create a load balancer. Our load balancer is now being created. Let's refresh this page to check the latest status of our load balancer. The provisioning status of the load balancer is now in creating. Let's wait for a couple of minutes and refresh the page again. My LB's provisioning status has been changed to active. Also, its operational status is online now. Click on the LB name to get more details about the load balancer. I will copy the ID of the load balancer to check the associated floating IP. From the left side panel, click on the public IPs. Let's search for the copied ID of the load balancer here to find the IP address associated with the load balancer. We have to map a DNS record with this IP address. I'm managing my DNS records on OVH Cloud itself. So let's click on Web Cloud to manage my DNS records. If you are managing your DNS records with any other providers, you have to add the record there. Expand the domain names from the left side panel. You can find my domain name techpk.site there. Click on the domain name to view my existing DNS records. These are the already added records in my DNS. Let's add a new entry by clicking Add an Entry button from the right side. We are mapping a IPv4 IP address. So click on A record. I will enter my LB as my subdomain name. Then I will paste the copied IP address to the target field. Click on the Next button to continue. We have to verify the record details here. The domain is mylb.techpk.site and the target is the IP address of the load balancer. All set. Click on the Confirm button to create the DNS record. We had added the DNS record successfully. You can view the DNS record on the bottom of the table. You can see the domain and the target here. It will take some time to reflect these changes. It may take a little while for these records to update across the DNS servers. In the meantime, let's go ahead and configure the Certbot. Click on the public cloud and then go to the instances page. Now we need to SSH into the Cert Manager instance. Just copy the public IP of the instance and open the terminal. Using my SSH key and the copied IP address, I am logging into the Cert Manager instance. I am inside the instance now and I am switching to the root user. Run the command certbot plugins to see all the installed plugins. Here you can see the certbot plugin for OVH Cloud. Now let's switch back to the browser and open the documentation for the Certbot DNS plugin for OVH Cloud. Certbot needs to create specific DNS records on my domain so that Let's Encrypt can verify that I own the domain before issuing the SSL certificates. To allow the Certbot to do this automatically, we need to provide it with a necessary credential to access and manage the DNS records. Since I am using OVH, I need to provide the API credential with the access permission shown here. This is a sample Certbot credential file for OVH Cloud. We will use the credential file along with the certbot command that requests the SSL certificate. Now let's create the credential file. I am copying the directory name from here and then we will switch to the terminal. I am already inside the Cert Manager instance now. First, we will create the directory here and then we will create the credential file inside it. Now, we need to copy the sample credential from the documentation page and use them here. I am pasting the copied content here. And now we need to replace the placeholder values in the sample configuration with our own credentials. I am using OVH Cloud Canada account, so my endpoint will be OVH-CA. For the remaining parts of the credentials, we need to create API credentials on OVH. Go to the OVH Cloud Manager page and then click on the profile in the top right corner. From the left side panel, expand the Identity and Security menu and then click on API keys. Click on Create an API key. Click on Continue to authorize your account. We will need to fill these details to create the API credentials. For the application name, I am entering Certbot plugin. I am also adding a description. The more details you provide, the easier it will be to identify the key's purpose later. I am setting the validity to 30 days, so the credential will expire in 30 days. Next, we need to assign necessary rights for the APIs. Let's refer the documentation to see which permissions Certbot requires. These are the rights that Certbot needs. With these permissions, it can create, edit, and delete DNS records for all the domains in the OVH account. For the production, I recommend narrowing it down to domain specific rights like this. I'm copying this rule and heading back to the API credential creation page. Let's paste it here under the rights for get, and then let's create similar rights for put, post, and delete. Finally, click on the create button. The API keys has been created. Now let's copy the keys and add them to the configuration file that we have created on the Cert Manager instance. First, copy the application key. Then head to the terminal and paste it on the correct place in the configuration file. We have to do the same for the application secret and the consumer key. Copy them one by one and paste them into the respective fields in the configuration file. Now, save the credential file and head back to the Certbot documentation to continue with the setup. We need to secure the credential file. Run chmod 600 with the file name. This sets the file permission, so only the owner can read and write the file, preventing others from accessing the sensitive keys. Now, we need to acquire the certificate from the Let's Encrypt. Copy the commands from the documentation and paste it on the terminal. We need to adjust the domain and DNS propagation time in the command arguments. The DNS propagation settings tells the Certbot how long to wait for the Let's Encrypt to verify the DNS record before issuing the certificate. Let's execute the command now. Certbot will prompt for an email to create an account. I am entering my email here. Next, we need to accept the terms and conditions. Enter yes to continue. I'm not sharing my email to receive updates from Let's Encrypt. So I'm entering no. You can choose to opt in if you want to. Certbot has requested the certificate from the Let's Encrypt. It will wait for 180 seconds to allow the DNS records to propagate. Now let's head over to the OVH console and check the DNS record for our domain. We want to confirm whether Certbot has successfully created the required records for the Let's Encrypt verification. You can see that Certbot has created a text record here. In our command, we have set a 180 seconds wait time. After that time, Let's Encrypt will query for this record. When it verifies the value, it confirms that we are authorized for this domain, and then Let's Encrypt issues the SSL certificates. Let's go back to the terminal. I will come back once the waiting period is over. See, our certificate has been issued successfully. You can see the certificate saved location here. Our certificates are currently in PEM format. OVH Cloud LoadBalancer doesn't support PEM, but it does support PKCS12 or P12 format. I have prepared the commands to combine and convert the PEM certificates into P12 format. The first command will combine the two PEM certificates from the Let's Encrypt into a single file. The second command will export this combined file into P12 format. After that, we will upload the converted certificates to the OpenStack Secret Store. Let's execute the first command in the terminal. I will replace the domain name with my own domain. Now let's run the second command. This command converts the combined PEM file into a P12 format. I will replace the domain name with my own. When running this command, it will ask for a password. I am leaving it blank and just pressing enter. Next, we need to upload the certificates to the OpenStack Secret Store. But before we can use the OpenStack commands, we will need credentials to connect. Let's head over to the OVH Cloud console and download those credentials. In the OVH console, from the left side panel under Project Management, click on the Users and Roles. Now click on the Create User button. We will need to enter a description for this new user. I am naming the user Certbot user, so it's clear what this account is for. Next, I am selecting administrator role for this user. Click on Validate. Our user has been created. You can see the password displayed here. Make sure to copy it and keep it somewhere safe because we will need it later. From the users menu, click on the download OpenStack's RC file. In the drop down, choose the region. In my case, that is London, UK1. Click on the download button. This will download openrc.sh files to the machine. Now we need to copy this credential file over to the Cert Manager instance so we can use it to authenticate with the OpenStack. Right now I am inside Cert Manager instance. Let's exit from here first and then copy the openrc.sh file from the downloads folder on my local machine to the instance using scp command. The file has been copied to the Cert Manager instance. Now let's SSH back into the instance. The file is now uploaded to Ubuntu users home directory. Next, we need to move it to the root users home directory. So it's available when we switch to root user. Let's load the OpenStack configuration by running source command on the openrc.sh file. This will set up all the environment variables that's required for OpenStack CLI to work. You will need to enter the password that we copied from the OVH console earlier. We have installed the OpenStack client in a Python virtual environment. We need to activate that environment before we can run any OpenStack commands. Now let's test our configuration by running OpenStack server list. See, our instances are listed here. That means our OpenStack client is configured properly. Now let's switch back to the browser and copy the commands needed to upload our certificates to the OpenStack Secret Store. I'm pasting the copied command into the terminal and replacing the domain with my own domain. As you can see, the certificate has been successfully uploaded to the Secret Store. Now, we need to use this certificate in our load balancer. The OVH Cloud console doesn't provide an option to import the certificate directly, so we will use the OpenStack Horizon interface instead. Horizon is a web-based dashboard for managing OpenStack services. Let's head over to the OVH Cloud console and click on the Horizon interface from the left side panel. The Horizon interface has loaded. From the drop-down menu at the top, select your region. In my case, the UK1 region was already selected, but I'm choosing it again just to confirm. Expand the network menu and click on Load Balancers. Our load balancer, my LB, is listed there. Click on the load balancer name. Click on the listeners tab. We don't have any listeners right now. Also, let's check pools. We don't have pools either. Let's create a listener now. Click on create listeners. We have to give a name for this listener. I will name it as web listener. Next, we need to choose the protocol. I am selecting terminated HTTPS. This option is not available in OVH Cloud console. That's why I am creating listeners on OpenStack Horizon interface. I am leaving other configurations with default values. Next, select these insert header options. This ensures that the applications running behind the load balancer can see the real client IP address. Click on the next to continue. We need to enter the pool details here. I am giving the name web pool. Also, I am selecting the algorithm round robin. For the other configuration values, I am leaving it as default. Click on the next to continue. Now we need to select the pool members. You can see the available instances here. Let's add all Nginx instances to the pool members. Once we have added them, let's add the port 80 to all the pool members. The Nginx web server is running on port 80. That's why I am adding port 80 here. Click on the next button to continue. Here, we have to add health monitoring for the pool members. I will name this monitor web monitor. I am choosing the type HTTP since we are monitoring the Nginx web servers. Let's go ahead by clicking next. This is the main part of our configuration, the SSL certificates. You can see the available certificates here. Click on the add button to allocate this certificate to our load balancer. Then click on create listener button. Our listener is now being created. Let's go back to OVH Cloud Console and check the status of our load balancer. Click on the load balancer name to view more details about the load balancer. Its provisioning status is now updating. Let's check the listeners. You can see the web listener that we have created from the Horizon interface. It's operational now. Let's check the pools. The operational status of the pool is online now. Click on the web pool to see the members attached to this pool. You can see the pool members here. The operational status of the pool members is showing online now. That means our load balancer is up and running. Now let's open a new tab in the browser and try accessing our load balancer using the domain name. See, we got the response from the Nginx web server. Let's check the security information for this site. As you can see, the connection is secured and it's verified by the Let's Encrypt. I'm refreshing this page couple of times to check whether we are getting response from all the Nginx servers. We got the responses from all 3 Nginx web servers. Our load balancer is working perfect. Let's check more details about our certificate. Let's Encrypt will issue the certificate with a validity of 90 days. The Certbot will automatically renew before it expires. Even though the certificate is renewed, Certbot cannot update it to the OVH Cloud LoadBalancer. I have prepared a shell script that will refresh the certificates on the load balancer. Let's check the script. We have to add the domain name and load balancer listener ID here. We need to add all necessary variables for connecting OpenStack client here. I will show you how to get these variables from the OpenStack RC file. Go to the terminal and run grep command on openrc.sh file to print all lines contains export. Let's use op command to remove the export from the output. As you can see, we got all the necessary environment variable that's required for OpenStack client to work. Anyway, this file doesn't contain the password for OpenStack user. We need to replace it manually with the password that we have copied earlier. Coming back to the script, there is a variable called OpenStack which stores the location of OpenStack command. If you are following this video, you don't need to change that variable. Otherwise, you have to go to the terminal and run which OpenStack to collect the OpenStack path. The script will first save the current certificate details from the load balancer into a variable. Then it will take the renewed certificate, combine and convert it into a P12 format and upload it to the OpenStack Secret Store. After that, it updates the load balancer with the new certificate and check for its operational status. Finally, the script cleans up by removing the old certificate from the OpenStack Secret Store. That's what the script does. We need to add this script onto the Certbot renewal hoop deployment directory. The Certbot will automatically run the scripts placed inside the renewal hoop deploy directory whenever the certificates are renewed. I am creating a shell script called lbupdate.sh inside the deploy directory. Now let's copy the script from the browser, paste it into the terminal and save it. Then let's replace the OpenStack credentials inside the script. Don't forget to add the password inside the script. The openrc.sh file doesn't contain the password, so you have to use the password that we have copied earlier. I will add my domain here in the script. Next, we need to get the listener ID. We have to get it from the Horizon interface of OpenStack. Just go to the listeners and click on web listener. You will find the ID here. I am copying this ID to use it on the script. Paste the ID on the script and remove the unwanted spaces. Now let's save the script and exit from the text editor. We have to give execution permission for this script. Otherwise, Certbot can't run the script. Now we need to test the script. Let's run Certbot renew along with force renewal. Our certificate has not yet expired. That's why I am using force renewal along with the Certbot command. This will take a moment to complete the process. I'll be back once the process is completed. See, our script has been executed successfully. You can see the logs. The script has replaced the certificates on our load balancer. Now let's head over to the browser and check the SSL certificates of our domain. I have refreshed this page couple of times to get the new certificate. Let's check more information about our certificate. Click on the View Certificate to get more details about the certificate. The validity time of the certificate has changed, which means the load balancer is now using updated certificate. And that's it. We have successfully set up SSL certificates on the OVH Cloud LoadBalancer using the Let's Encrypt and Certbot. Also, we have automated the renewal process with a deployment script. This way, you will never have to worry about expired certificates again. Thanks for watching, and I will see you in the next video.